So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on the xt graph and other graphs related to the motion of a particle. So here is the question: a particle is moving along x-axis and xt graph is shown in the figure. It's a sine curve and we need to find x max. So x max is a dash, x minimum minus a dash, x max plus x minimum. If you add these two, it's 0. X max minus x minimum dash, so it is twice of a dash, ratio is -1, magnitude is 1. X is positive as, so you can see in the graph x is positive at a, b and c. Then is x is negative at, you can see that it is negative at e, f and g. Then is x is 0 at, so x is 0 at d and h. Then velocity is positive as, so velocity is given by the slope of xt graph, and you can see that slope is positive at a as well as g. So it's possible at a and g, and obviously at h also, because it's a sine curve, so velocity will be cos curve. Here sine is 0, so cos will be 1 over here. So at a, g and h, velocity will be positive. Then is velocity is negative at, so velocity negative means negative slope. So slope is negative at c, d and e. Then is velocity is 0 at, so obviously slope is 0 at b and f, so velocity is also 0 at b and f. Then is speed is positive at, so speed is always positive except during when it is 0, which is at b and f. Then next question is speed is negative at, so speed is never negative. Then is speed is 0 at, so it is 0 when slope is 0, which corresponds to points b and f. Then is acceleration is positive at, so acceleration is given by the you can say that the shape of the curve. Acceleration is positive when shape is concave upward, which corresponds to the lower part. So acceleration is positive at ef and g, as you can see over here that at e velocity is negative, at f it is 0, and at g it is positive. So acceleration is positive as velocity is increasing in this part. Then is acceleration is negative. So similarly, if shape is concave downward, so we can see that acceleration at a, velocity at a is positive, at b it is 0, and at c it is negative. So we can say that acceleration is negative during the part ABC. Then is acceleration is 0. So obviously acceleration is 0 at d and h, because they corresponds to the 2 point. Here acceleration is negative, here it is positive, so here it has to be 0. Then acceleration magnitude is maximum at, so acceleration is maximum at b and f, as we can say that x is sine curve, so acceleration will be minus of sine, so mod will be about magnitude of sine curve. So acceleration will be maximum when the sine value is maximum, or when x is maximum, which corresponds to b and f, and its magnitude is minimum at d and h when x is having minimum magnitude. Next question is time period of the graph. So from here we can see that graph repeats after 10 seconds. So let me to elaborate that more. It is just like that. So the time period here is 10 seconds. Then we have angular frequency. So angular frequency is 2 pi by t, so which will be pi by 5 radian per second. Next is frequency. So frequency is 1 upon time period, so that will be 1 by 10 hertz. Then is the xt relation. So xt relation is a sine curve, which is a dash sine omega t. Omega here is pi by 5, so x is a dash sine pi by 5t. Then is velocity time relation. Velocity is dx by dt, so that will be a dash pi by 5 and cos pi by 5 into t. Then we have mod vt relation, or the speed time relation, so it is a dash pi by 5 mod cos pi t by 5. Then is at relation. Differentiating this equation again, we have a dash pi by 5 whole square and minus of sine pi t by 5. Then we have mod at relation. So taking the magnitude, we have this thing. Next is vx relation. So v is equal to omega root a square minus x square. Omega is pi by 5 here, so it will be v is equal to pi by 5 root a1 square minus x square. Then is ax relation. So a is minus omega square x. After solving the questions, then we have a is equal to minus pi square by 25 into x. Then we have value of x at t is equal to 2. So that will be a dash sine 2 pi by 5. If we substitute t is equal to 2 over here. Then is x at t is equal to 4. So it is a dash sine 4 pi by 5, as we can solve over here. Then is x at t is equal to 6. We have a dash sine 6 pi by 5, as we can see over here. So you have seen that these are the optimal physics worksheets, and we have covered the content of up to 1 hour in a duration of 3 to 5 minutes. So if you have studied XT graph in kinematics, then it's a time to check your understanding through these worksheets. So the optimal worksheets are designed with the purpose to serve you as a testing mechanism that what is your learning output. So we have optimized these for the performance, and you should be able to complete all the question within 5 to 7 minutes, so that you can check yourself that what is your understanding of the current topics. Thank you and have a nice day.